Hi, in this video we're going to talk about another class of function called the logarithmic functions. So first we define what logarithmic function is. Um, let b be a positive real number. So let this be a positive number. So it should be greater than 0, positive real number, such that b is not equal to 1. So again, b is a positive real number except 1. So 1 is not included for a possible value of b. The logarithm of x with base b is denoted by, so this is the symbol. The logarithm of x with base b, denoted by this, is defined as y equals logarithm of x with respect to b, with base b, if and only if x equals b raised to y. So with this phrase, it means that this and this are equivalent expressions. So what is really the meaning of this logarithm of x with base b? If you look at its equivalence, you'll have an idea that y here, which is our logarithm of x with base b, is actually the exponent of b, so that the answer will be x. Okay, so as you can see, to make it short, the logarithm is actually the exponent. Okay, so the logarithm is the exponent of base b, so that the answer will be x. Okay, so a function defined in this way is called the logarithmic function. Okay, so there are two cases that we are to consider here. First case, if b is if b is greater than 0, that's a positive, but less than 1. And the second case will be if b is greater than 1. So what is the graph of the logarithmic function if this is the case? Okay, so the graph of this looks like this. So the graph of the function f defined by f of x equals log of x with base b, where b is greater than 0 but less than 1, looks like this. Okay, so the x-intercept is 1. So note that the graph of f defined by f of x equals log of x with base b is this one. Okay, and this one is our this is the vertical asymptote of the graph. So we already knew what a vertical asymptote is. So this is the rough sketch of our f defined by this. If your b is between 0 and 1. Okay, Next is, for the second case, we have if your b will be greater than 1. So function f defined by f of x equals um, log of x with base b. Okay, where your b is greater than 1, so you know what numbers that are greater than 1, 1.25, 2, and so on and so forth. So if that is your b, then the appearance of your graph looks like this. It's 1. Okay, and again, this one is our vertical asymptote. So meaning the graph now approaches to, our graph approaches to this line x as x approaches to 0. Okay, when your x approaches to 0, your graph approaches to this vertical line. Okay, so this is just a sketch graph of our logarithmic function f defined by this, where your b is greater than 1. So example, if your function is defined by, let's say, f of x equals log 5 log x with base 5, so the graph of this function f right here defined by this roughly looks like this. Okay, similarly, if we have function here of f defined by log x with let's say you have 1/2 with base 1/2, so the graph of this roughly looks like this. Okay, so whenever your b is between these values. Okay, so that is the rough sketch of our graphs considering the two cases. So let's go to some characteristics of our logarithmic function. Now, first is the characteristic of logarithmic function defined by y equals log of x with base b. So the domain of this function, f defined by this consists of all positive real numbers. So the domain of our logarithmic function consists of all positive real numbers. So going back to the graph, you will see that yes, indeed, that's the case, because looking at this, we'll see that the permissible values of x are those that are positive. Okay, so you collect all these x's here, so the domain of our f right here are actually the set of all positive numbers, real numbers. Same with this. Okay, the domain of our f is all positive integers, or you can write this as set of all x such that x is greater than 0. So these are only the permissible values of x that we can these are only the possible values of x that we can plug in our f, so that we can define, so that f is defined. Okay, so here we have okay, similar. So that's the domain. Okay, if you look at this, okay, the domain, the permissible values of x that we can only find is the set of all x greater than 0. So all of these things, you collect this one, put it in a set. So this is the set now, or this one. Okay, so you cannot plug in other words, you cannot plug in x here that are negative numbers or 0. So you cannot plug in 0 or negative. Similarly for this, okay, you cannot plug in uh, negative numbers or 0, only positive, because the domain is the set of all positive uh, values. Okay, now the range is the set of all real numbers. While the range is the set of all real numbers, as you can see, um, so it extends here in infinity and to this side as well. So uh, as you can see, the range is the set of all real numbers. So we already tackled that one. So the set of all real numbers, so that's the range. Similarly here, so it extends infinity in this side and in this side. So as you can see, the range now is the set of all real numbers. So the range of f is the set of all real numbers. Or you can write this in other way. So this is set of all y such that y is an element of real number, or this. So you can have y such that y is an element of real numbers. Okay, next characteristic is that the graph passes through the point 1, 0. So it's very obvious in our graph that the graph really passes at that point. Okay, so as you can see, it passes the point 1, 0. Similarly, for this, we have 1, 0. So the graph passes at point 1, 0. So the x-intercept is 1. Okay, next, if b is greater than 0, b is greater than 1, the graph of this approaches but never touches the y-axis. Okay. So it is obvious that if b is greater than 1, the graph of this approaches but never touches the y-axis. As well as for when b is between 0 and 1. Okay, so as you can see, this graph right here approaches to this as but never touches the y-axis. So it never touches the y-axis. As well as this, it never touches the y-axis, but the graph approaches to that line. Okay. Okay, next so of course the y-axis is an asymptote, or the vertical asymptote for the logarithmic function, whatever is the case, whether the b is between 1 and 0 or the b is greater than 1. Okay, so we have some remark here. The exponential function and logarithmic functions are inverses of each other. So it's important to note that what we have learned last time, the exponential function and the logarithmic functions are inverses of each other. So we will use this idea that this and this are inverses of each other, because when we will graph the logarithmic function, we will use the exponential function. So what does it mean when exponential function and logarithmic functions are inverses of each other? We've already discussed the inverse of a function. So when one function is an inverse of the other, therefore when you graph that function, it is actually a reflection with respect to y equals x. So the graph of the other function is a reflection with respect to y equals x. Now, for example, we have this. We already knew the graph for the, let's say, an exponential function. We have y so let's say we have y equals with base b, and let's consider the first case, which is where our b here is greater than 1. Okay, so remember the definition, they are just equivalent. Okay, this one, y log of b log of x with base b is equivalent to when you say x is equal to b raised to y. This is the y, so that's the exponent. So we will do that here. So which means to say that okay, this is just equivalent. X equals y, no, it should be b raised to y. So what we will do here is that we are going to graph this first, okay, and then draw the line with equation y equals x. We already knew that the graph of this divides the first quadrant and the third quadrant. So let's say we first draw the y equals x. Okay, so this is the graph of the line with an equation y equals x. So we already knew what is the appearance of this. What's the appearance of this graph, of the graph of this exponential function defined by that equation? Since we already knew that the exponential function and logarithmic functions are inverses, so first we will draw the exponential function defined by this. Okay, so how does it look like when we graph this one? when you graph the function defined by this, if your b is greater than 1. So it looks like this. Okay, remember the x-axis is the horizontal asymptote. Okay, now to draw this one or sketch this one, just sketch the reflection of this graph, which is this one, with respect to y equals x. So the graph now looks like this. So this is just a reflection of this graph with respect to this. So let me use another color. And now remember that the y-axis is the vertical asymptote of this. Okay, so now the graph of this is this one. So what does it imply? So it implies that we are going to use the exponential um, uh, equivalence of this logarithmic uh, equation so that we can graph this one. Okay, so that's the implication for our remark. Similarly, if you're going to draw where in the case for y equals logarithm of x with base b, okay, we will draw a y equals x line. So we will use the y equals b raised to x when b is, remember our b now is so when you graph this one, when you graph the function defined by this, when b is between 0 to 1, so the graph looks like this. Okay, now we've already sketched the graph of the equation, the graph of the function defined by this equation. So now it's time for us to graph this. So when your b is between 0 and 1, so just sketch the reflection of this with respect to this line. So this is the mirror, the reference. So to do that, okay, to find the reflection of this with respect to this line, okay, of course you're going to use this one, and then you draw a reflection of this, and then the reflection of this with respect to this is it looks like this. So the reflection of this is this one, and the reflection of this with respect is this one. So we will combine. So this is the graph of our function with defined by this when your b is this one. Okay, so The graph is not so perfect. So now the graph of the function defined by this is this one in green. So if we go back, okay, to the previous sketch, so as you can see, we have this one. If your b is between 0 and 1, so the graph looks like this. Indeed, the graph looks like this. Similarly, if your b is greater than 1, so the graph of the logarithmic function looks like this. So yeah, this is the appearance of our graph. So please stay tuned for the next part of this video. I will show you how to graph the logarithmic function by using its equivalent exponential equation. And as we have learned, we will use the line y equals x as our reference of our reflection to graph these kinds of function defined by this. So that would be all. Thank you very much and have a nice day.